Hi everyone, insertion sort is my topic. Insertion sort. Insertion sort is about as twice as fast than bubble sort. It chooses element as pivot and compares with all the previous element from the beginning of the array. And if the pivot is smaller than insertion is done. If not, comparison is done with the next element. In the first iteration, pivot is set to 1 and pivot is incremented after every iteration. These steps are repeated till pivot reaches the last element in the array. Insertion sort is table method of sorting. Here is the detailed insertion sort algorithm. In first step, we have to add the first element to the sorted side. In the second step, insert the second element in the second position and towards the sorted side. In the third step, if the second element is less than the first one, swap them. In the fourth step, insert the third element in the third position on the sorted side. In the fifth step, if the third element is less than the second one, swap them. If now second element is less than the first one, swap them too. Proceed in this way until all the elements on the unsorted array moves to the sorted array. Basically, in a insertion sort, an array contains a sorted array. We have to take the array as sorted and unsorted. First element is taken as sorted, which we should not compare it, and other is unsorted. Here we have an array of size 5 with elements 9, 5, 1, 4, 3. 9, 5, 1, 4, 3. Here 5 is taken as key. Now 5 is compared with 9, where 9 is greater than 5. So 9 got swapped, whereas 5 remains there only. It checks whether any element is preceding to 9. There was no element, so it got swapped, and the final array is 5, 9, 1, 4, 3. Below he gave that if the first element is greater than the key, then key is placed in front of the first element. We have done that. Next, step 2. We already swapped 5, 9. Here is the array 5, 9, 1, 4, 3. Here 1 is taken as pivot, which is key. Here first 1 compares with 9, whereas 9 is greater than 1. So 9 got swapped. And 1 remains there only, and it compares with 5, whereas 5 is greater than 1. So 5 got swapped. 1 remains there only, whether it checks any element preceding to 5. There was no element, so it also got swapped, and the final array is 1, 5, 9, 4, 3. And in the next step, we already swapped 1, 5, 9. Here we have to sort 4 and 3. In this step, we take key as 4, which is pivot. 4 compares with 9 first, whereas 9 is greater than 4. So 9 got swapped, whereas 4 remains there only. And 4 compares with 5, whereas 5 is greater than 4. So 5 got swapped, 4 remains there only. Where 4 remains there only, it checks with 1 whether it is greater or not. Whereas 1 is less than 4, so it remains there only. The sorted array is 1, 4, 5, 9, 3. One element is remaining for sorting. In the final step, we already sorted 1, 4, 5, 9. Here we have 3 remaining, which is taken as pivot, and it is key. 3 is compared with 9, whereas 9 is greater than 3, so 9 got swapped. 3 remains there only. 3 is compared with 5, whereas 5 is greater than 3, so 5 got swapped. And 3 remains there only. It checks whether 4 is greater than 3 or not. We know that 4 is greater than 3, so 4 got swapped. and 3 remains there only, checks with 1 whether 1 is greater than 3 or not. We know that 1 is less than 3, so the final sorted array is 1 3 4 5 9, and we get the final array. This is the insertion sort example logic. And in the next step we will discuss about logic. Here is the logic. Insertion sort logic. We know already how to read the elements and initialize the terms using for loop for I equal to 1, which is pivot, and size minus 1, which is n minus 1, and a list of I, which is array size, is assigned to temp, where j is I minus 1, which is preceding to pivot, while temp is less than array element pivot and j is greater than 0. And the list of j minus 1 is assigned to list of j, where j is decremented, which is j is equal to j minus 1, and at last temp is assigned to list of j. In the next step we will discuss about the program. Here is the example program. We take two header files, standard input output device and conio.h, and void main function. We initialize the terms size I, j, temp, and array of 100. In printf, enter the size of the list. We have to enter how much size of the array we want, and scanf. Here we have to declare the elements of the array. And using the for loop we scan the elements. Here is the insertion sort logic. For I equal to 1, whereas I less than size, we have to sort the elements up to size minus 1 terms only, not up to size. So we take as I minus I less than size, whereas I incremented. In the loop, list of I, which is array of I, is assigned to temp, where j is equal to I minus 1, which is preceding to pivot. Whereas temporary value, which is pivot, is less than the preceding value of pivot, and j must be greater than or equal to 0. In these two conditions only it goes inside, whereas list of j is assigned to list of j plus 1, where j is decremented, which is j is equal to j minus 1, and then temp is assigned to list of j plus 1. At last we can print the array elements, which is a list after sorting. Using this for loop we can print the elements of sorted array. Here is the output. We can enter the size of the list and then the elements, 5 elements which are unsorted, and after that we get sorted array. The most important one, time complexity of insertion sort. We have 3 cases in insertion sort: worst case, best case, and average case. First case occurs when the array is in descending order but we want ascending order. If it is in descending order, we have to check every element of n and compare every element. It is different. It is difficult. So the order becomes 0 of n square. Best case is when the arrays are already sorted, which is ascending order. The order is n. Average case, we already know that. That's it. Thank you for watching.